So the next session is on the era of cloud gaming, powering up competitive multiplayer experience. And we are very delighted to have Mr. Eric Lin, Business Development Manager, Amazon Web Services, and Mr. Clifford Duke, Solutions Architect, Amazon Web Services, to share on what AWS is doing in cloud gaming to level up competitive multiplayer experience. Eric possesses over 20 years of experience working with various organizations in technology sales, consulting and research and development. In his current role, Eric is responsible for helping digital native customers to develop cloud-enabled innovations to deal with rapid growth in short periods of time, as well as helping them to build a data-driven organization by leveraging AWS technologies. And Clifford comes from a software development background and is passionate about helping customers build secure, reliable, and scalable solutions for the modern cloud. So ladies and gentlemen, without further ado, let's hear from Eric and Clifford.
Hello, everyone. Thank you for joining us, and thank you to Cyberport for having us here today. In the next 15 minutes, we're going to talk about how AWS can help you to power up your multiplayer competitive games in minutes and in a cost-effective way by leveraging one of our Amazon managed service called Amazon Game Lift. My name is Eric Lin. I'm responsible for digital native business development for AWS in Hong Kong. And together with me, we have Clifford Duke, our solutions architect, also from AWS Hong Kong. Now, Clifford, right? As you know, there are many. Typically, for the game developer, right? They have been came across with a big questions decision on whether they should use peer-to-peer or dedicated game server as the underlying infrastructure to serve their games. So, Clifford, what is your preference on this and why?
Well, there are benefits to both sides. With peer-to-peer, it's the lower barrier of entry. It's simpler to actually get started. But you end up having a lot of issues such as client-side cheating because you end up having a single host, a player be the host, so there's no protection there. You also have a more inconsistent player experience because one person acts as the host, which will have a lower latency. So, of course, I think dedicated would be a lot better. However, it does have its own issues.
Okay, so seems dedicated is the way to go, but in my mind, there are still a couple of questions regarding the on-premises dedicated server architecture because from the latency and scalability and cost perspective, I'm still wondering how we can get it resolved. Because if you set up one dedicated game server in a single geographic location, you may end up with players connecting to it from different parts of the world. So they are really heavily relying on the public internet to connect to it. And secondly, right, the number of players of the multiplayer games could vary a lot. It can be a few to hundreds of players joining one single game section at a time, at the same time. So how to handle this scalability issue, how to scale up your server is really a big challenge. Obviously, right, if you set up the second or third game servers in other locations, in other continents, of course, it can help to lower the latency, but in the meanwhile, it will jet up another issues like the cost and the ongoing server maintenance. So having said that, right, I think the most important part right now is the underlying infrastructure has to be flexible enough to support our matchmaking algorithm so that we can effectively funnel and group the player with similar skill set and latency into the same gameplay. And in particular, the matchmaking challenges, right? There's always a balancing act between the wait time, competitiveness, player latency, and cost, right? So as you know, right, wait time and competitiveness are inversely proportional, which means that a longer wait time would allow you to have a high chance to come up with a more fun and competitive game. But in practice, right, people do not want to wait for that long. They want to be placed into a competitive match immediately without any time lag, right? So from this perspective, I think balancing all of them at once is really challenging and time-consuming. So, Clifford, do you have any idea or suggestion to us to overcome these challenges?
Yes, so basically we took these problems that a lot of our users have faced and created a service dedicated to help solve these issues. That's where we came up with Amazon GameLift, which is a fully managed service that helps you deploy, operate, and manage low-cost servers for session-based multiplayer games. Now, it simplifies it in a lot of aspects, where we take a lot of the undifferentiated heavy lifting of hosting your own session-based game and simplify it so that you don't have to spend hours of engineering effort to do the same things that other people have done. We leverage our global infrastructure to allow for a low latency experience for your end gamers. And there's a lot of different features that I'll cover in a little bit that enable you to create these session-based games much faster. So quickly, how does GameLift work? So in a traditional architecture, you might have a gateway for your game client to connect to. You have your backend services that will help do the matchmaking, start the queue for users. And then once they find a group of people that are of same skill, similar skill, they will then pass it on to a server cluster to handle the actual game session. With Amazon GameLift, all this is done for you, where there's three portions of GameLift, where there are three parts of GameLift basically. We have our Flex Match system, which helps you create very simple rule-based ways of matchmaking people. We have our Fleet IQ, which intelligently routes people to the lowest latency region. And then you have your fleets, which contains all the actual servers for your gaming session. So let's see an example. So let's say you have you start off your game, you worry about not having enough players, so you end up with a single matchmaker queue. So around our global infrastructure, you'll have a lot of these different game servers hosted. Then you'll have a single matchmaking queue where everybody from around the world will then connect to. When it finds people with similar skill sets or based on what your own rules are, it will then group them up, define them together, and then find a server that's close to them, and then connect them all together. Now, the upside of this is that you get more players to choose from, but the downside is that they might not have all the similar latencies or close enough latency. So in this example, let's create a custom rule for our Flex Match. So with Flex Match, you can just define very simple stuff like rules. So in this example, I'll be creating a 2-game team. We pass in a player, they have a player attribute, such as a skill, and then we define how many teams we want. So we have 2 teams, minimum of 3, maximum of 5 players. You can always change this up depending on what kind of game you're creating. After which, you have your rules, which is all very declarative, very simple declarative rules. For this example, we have our first rule, which is fair team skills, where we take the average of the players and try and keep their skill set close enough. The second rule is that we want them to have fast connections, so we make sure that their latency is below 50 ms. However, you might not have enough people to fit that. So we also allow for expansions, where after a certain amount of time, you can start increasing or relaxing the rules. For this example, you can increase the latency to a bit higher if they wait too long. So after 10 seconds, you relax the requirements to 100 second latency. The second way of doing things is by doing the same. You have your global infrastructure, but you have matchmaking queues in each region. And then each player will connect to the closest matchmaking queue to be paired up into a game. The upside of this is that you have a lower latency for each player, but you may have a fragmented player pool, and if you don't have enough players, you might see increased wait times. So in this example, we don't have to worry about the latency as much because they're already really close. So what else can we do with the rules? With our expansion, we can also set the original fair team skill rule and change it up so that if it takes too long, we allow for a wider range of skill levels to put them together.
I think this is a great feature, Clifford. Especially it can save the game developer a significant amount of time so that they can focus more on the game itself. How about the cost issue that we mentioned earlier? Do you have any suggestion to help us?
So GameLift helps with this as well. In a typical game demand curve, you might see more players playing the game at night versus in the morning. So this will be a typical game curve that you'll see. In a traditional infrastructure, you might end up having to provision to meet the highest demand throughout the day. So what happens here is that you end up having in the morning wasted resources that are sitting there idle, which leads to wasted resources. However, the other side also has an issue where if you don't provision enough and you do end up having a spike of users, let's say you launch a new update, you end up having too many players for your infrastructure to handle, and then you'll have a bunch of sad players with not enough resources to use. So with GameLift, with the fleets, they have auto-scaling capabilities. So they auto-scale based on the demand on how many players are playing the game, and basically there's a bunch of different metrics you can monitor to maintain the minimum amount of devices, minimum amount of instances for that time. This allows you to keep the curve of resource utilization as close to your demand. Another thing is that in traditional infrastructure, you have excess capacity, so it doesn't matter where you put your instances. However, with GameLift, we can help automatically pack instances with a number of game sessions so that those excess capacities can be scaled down when it's not needed. So the placement logic is very simple. When the game comes in, it will then pick the lowest latency for the game to start. But you might ask, okay, so this is great. How do I save even more? Is there any other way we can save? So with AWS, we have something called spot instances, which are basically excess capacity that is given at a discount. The downside of this is that they may be reclaimed after a period of time if the demand goes up. You do get a 2-minute window to shift your workloads away from that, but you might be asking, with Spot, this doesn't sound quite good for these kind of games. This is why we introduced Fleet IQ, which basically intelligently picks the right instances to deploy your workload, therefore reducing the chances of having interruption. So this uses a predictive algorithm to pick the least likely instances that will affect you. So in this example, we have 2 instances where it can pick from. One is a Spot X large, one is on-demand C5 large. What it finds out is that the Spot instance for the X large is actually cheaper, so it will then pick that instance. Another feature for the placement queues is that if that region has too much demand, you can also fall back to another region, the next nearest region, for roughly around the same cost. So in conclusion, basically, Fleet IQ can help save costs by continuously rebalancing, finding the right spot instances for you, and reduce the likelihood of it being reclaimed.
This is great, Clifford, again. So I think for some cases, when people still have some on-premises equipment, they may need some time to migrate to the cloud, right? Mm-hmm. So does Fleet IQ be able to support that?
Yes, actually. So there are a couple of new features with GameLift. First of all, Flex Match has been updated so that it's now agnostic, independent from all of the features. So you can have Flex Match help your matchmaking engine point to any servers if you're on premises or in the cloud. Another feature of Fleet IQ is that it is also independent, so you can now leverage AWS and the Fleet IQ for excess capacity, as opposed to moving all in.
Okay, so let's move on to the final slide. So in summary, right, GameLift is a fully managed service to help you to power up your game in minutes and in a cost-effective way, right? So by leveraging our AWS global infrastructure, all the players can now be connected to our closest data center locations so that it can achieve a latency of 45 milliseconds in averages. And also it can quickly match up the starting time with below 100 milliseconds. And also it can help you to save up to 70% of your cost versus the co-location solution. So focus on your game and then leave all the heavy duty work to AWS so that you can further improve your player experience. Okay, thank you so much for your time. Thank you
very much.
Thank you. Thank you, Eric and Clifford, for the wonderful sharing. It's inspiring to learn what AWS is doing with their top-notch cloud technology to power up the gaming experience.